So let's discuss this beautiful topic. Here we are going to define types of random variable and we are talking a lot about it. First of all, discrete random variable. So here we have something called PMF. PMF is the shorthand notation for probability mass function. What does that stand for? Something written in mass. Okay, so nothing to worry. What we are going to discuss is probability mass function. Suppose we have a function fx. Okay, then any such function which will give me value f of a is same as probability of x equals to a. That is called probability mass function. So the other case that we are discussing in continuous variable is called probability density function. So P stands for probability, D stands for density, and F stands for function here. So what are we doing it? We are taking an extension of PMF to show what we have in PDF. So suppose we have a function called f of x. Okay, we are putting the value f at a region. Okay, for example, this graph we have AB as the region R. Then f of R will give me what it will give. It will give me the probability of x in between B and A. That is the thing that I am getting here. Okay, so PMF is probability mass function that gives probability at a particular point whose extension is probability density function. Okay, with that in mind, let's move ahead. We are going to discuss more about this. So something that I am going to tell you right here is what can be done with these things in mind. Suppose I define something like this: f of a is equal to probability of x less than equal to a. This thing will give me cumulative distribution function called CDF in shorthand. Cumulative distribution function. Okay, what does that give? So anything defined as f of a is equal to probability of x less than equal to a. So probability of x less than equal to a, we are going to define it here. Let's see. In this case, suppose this is discrete. Suppose we have random variables a1, a2, a3, a4, and I want to find f of a4. So it will give me probability of x less than equal to a4. And how am I going to find it? I am going to find it by doing summation. The summation of all the probabilities less than or equal to a4. That is I equal to 1 to 4. I have to count this area, this area, this area, and this area. Right? Similarly, in case of this continuous random variable, how am I going to find probability of a4? Suppose I have a4 here. Okay, in that case this summation will not work because summation gives the sum in this discrete case. In continuous case we have to do integration. Since this is starting from the origin 0, let us assume for a moment that it starts from the origin. So I have to integrate from 0 to a, and the function f of x can be written here with dx with it. So this integral will give me the area under this curve till I find a. I hope that is clear to you. I have to see you in the next video.